December 1941, near Moscow. A German panzer crewman, huddled in his frozen tank, scribbles a letter home describing the strange Soviet rifle he's just examined, captured from a fallen Red Army soldier. It's built like a peasant's tool. He writes, rough wood, crude machining, stamped metal parts where ours are precision milled. The bolt rattles. The trigger is heavy. On paper, this weapon is inferior in every measurable way. 3 months later, that same crewman would be dead, killed by a Soviet counteroffensive in which those very crude rifles fired through temperatures that had frozen German weapons solid. His Karabiner 98K, a masterpiece of Weimar engineering with its polished action and hand-fitted tolerances, had become a club. The Soviet Mosin Nagant, built in factories evacuated across the Urals, assembled by workers with minimal training, went on firing. This wasn't an isolated incident. From Leningrad to Stalingrad, from the forests of Belarus to the streets of Berlin, German forces encountered Soviet weapons that defied every principle of proper military engineering. The PPSH-41 submachine gun, stamped from sheet metal. The T-34 tank, with its crude welds visible from 50 meters away. The 76mm ZIS-3 divisional gun, designed to be produced by semi-skilled labor in non-specialist factories. Wehrmacht after-action reports described these weapons with a mixture of contempt and unease, primitive, agricultural, built to quantity, not quality. Standard military thinking in 1941 held that wars were won by superior technology, precision manufacturing, and educated soldiers operating complex systems. The Red Army proved that crude, simple, and mass-producible could defeat refined, complex, and scarce. This wasn't accidental neglect or technological backwardness. It was a deliberate design philosophy, one that understood something the Germans had fatally overlooked. Battlefields aren't testing ranges, soldiers aren't engineers, and a rifle that fires in Siberian winter is worth more than one that shoots tighter groups in Bavaria. The Mosin Nagant rifle, introduced in 1891, was already obsolete when the Great War began. By 1941, it was positively ancient, a design predating the dreadnought, the aeroplane, and the internal combustion engine in military service. German intelligence reports from the 1930s noted with satisfaction that the Red Army still relied on this museum piece as its standard infantry rifle. The Wehrmacht's own Karabiner 98K represented nearly 4 decades of refinement. A Mauser action honed to perfection, tolerances measured to thousandths of an inch, every component machined from forged steel. A Kar 98K cost approximately 70 Reichsmarks to produce in 1940. It required 27 separate machining operations on the bolt alone. Each rifle demanded roughly 45 man-hours of skilled labor, much of it performed by workers who'd served apprenticeships in Germany's legendary arms factories. The Mosin Nagant, by contrast, cost 163 rubles in 1942, equivalent to about 28 Reichsmarks at wartime exchange rates, less than half the price of a German rifle. Soviet factories produced them in 21 hours of labor, using workers who'd been farmers 6 months earlier. The stock was rougher, the finish was non-existent, the sights were cruder. In bench rest testing at the Kummersdorf proving grounds, captured Mosin Nagants grouped at 4 to 6 inches at 100 meters. The Kar 98K managed 2 to 3 inches. German ordnance officers concluded what seemed obvious: Soviet infantry would be outshot by better-equipped Wehrmacht troops. On paper, this shouldn't have worked. A crude rifle with worse accuracy, heavier trigger pull, and rougher action should have been a liability. Yet captured German documents tell a different story. A 1942 after-action report from the 6th Army at Stalingrad notes, "Enemy small arms continue to function in conditions that render our own weapons inoperable. Temperatures of -35 degrees Celsius cause complete failure of our rifle actions, whilst the Russian Mosin continues firing." Another report from Army Group Center in January 1943. The crude tolerances of Soviet weapons, which we initially regarded as evidence of poor manufacturing standards, appear to provide significant battlefield advantages in winter conditions. What made this work wasn't any single feature, but rather a design philosophy born of Russia's climate and industrial reality. The Mosin Nagant had been designed in 1891 by engineers who knew Russian winters. Its tolerances were deliberately loose, gaps of 0.008 to 0.012 inches, where German weapons held to 0.002 inches. This seemed like sloppiness. To a Soviet infantryman in the siege of Leningrad, where temperatures reached -40°C, it meant the difference between a functional weapon and a pretty club. Ice, mud, and powder residue that jammed tight German actions simply rattled around harmlessly in the Mosin's looser mechanism. The secret was in its crude simplicity. The Mosin Nagant had fewer parts than the Kar-98K, just 65 components compared to 79. Its bolt was a straight cylinder, not the sculpted and polished German piece. When it got dirty, you stripped it in 30 seconds with a punch and a rock. The Kar-98K required proper tools and a clean workspace. German soldiers, interviewed after capture, consistently remarked on this difference. Lance Corporal Wilhelm Hoffmann, captured at Stalingrad in January 1943, stated to his NKVD interrogators, "We were told Russian weapons were crude. They are crude. But crude means they work when ours freeze. I watched our sergeant weeping because his rifle wouldn't fire whilst the Russians shot at us with rifles older than he was." This extended to manufacturing. Ijevsk Arsenal, one of the main Mosin production centers, was evacuated 1,400 kilometers east to Sverdlovsk in October 1941. Within 3 months, partially trained workers in improvised facilities were producing 12,000 rifles per day. The tolerances got even looser. The finish became almost non-existent. Some wartime Mosins had visible tool marks on the receiver. None of this mattered. Between 1941 and 1945, Soviet factories produced 17.4 million Mosin Nagant rifles. German factories, with their superior machine tools and skilled workers, produced 7.8 million Kar-98Ks in the same period. Germany couldn't replace losses. The Soviets buried the Wehrmacht in functional, if crude, rifles. The deeper principle here was what Soviet engineers called dostupnost, accessibility. Not just affordability, but producibility. A weapon wasn't good if it required specialist factories, skilled workers, and months of manufacturing time. It was good if you could make millions of them, if they worked in soldiers' hands, and if they kept working when those hands were frozen or muddy or shaking with fear. Critics argued that this represented technological backwardness. They were right about the technology being backward. They were catastrophically wrong about what mattered in total war. The Wehrmacht's MP-40 submachine gun was a marvel of 1930s manufacturing. It employed progressive stamping, spot welding, and minimal machining. By the standards of 1940, it was revolutionary, a weapon that broke from traditional hand-fitted manufacturing. Hugo Schmeisser's design team had reduced production time to 27 hours per weapon. The Army was delighted. Between 1940 and 1945, German industry produced approximately 1.1 million MP-40s, arming perhaps 15% of frontline infantry with automatic weapons. Then came the PPSH-41. Soviet designers, looking at captured MP-40s in late 1940, concluded they were still too complex. The PPSH, designed by Georgy Shpagin and approved for production in December 1941, took stamping to its logical extreme. The receiver was 2 pieces of stamped sheet metal, spot welded together. The barrel shroud was a simple steel tube. The stock was rough wood or laminated plywood. The 71-round drum magazine was crude, heavy, and prone to rattling. Total parts count: 87 components, including the magazine. Total machining time, 7.3 hours per weapon, including all finishing operations. Cost, 142 rubles in 1942, falling to 78 rubles by 1943 as production techniques improved. German intelligence reports from early 1942 described the PPSH with barely concealed contempt. One OKW assessment noted, "The Soviet PPSH-41 represents a weapon manufactured entirely from stamped components of the lowest quality. Finish is non-existent. Tolerances are grossly excessive. The trigger mechanism is crude. The weapon's only virtue is simplicity of manufacture." Another report observed that the distinctive sound of the PPSH, a slower rate of fire than our MP40, indicates poor ammunition feed and mechanical inefficiency. This shouldn't have worked. A cheap stamped weapon with a crude drum magazine should have jammed constantly. The slower rate of fire, approximately 900 rounds per minute compared to the MP40's 500 to 550, should have been wasteful. The heavy, rattling drum should have been a tactical liability. Wehrmacht doctrine emphasized controlled, aimed fire. Soviet infantry doctrine, especially after 1942, increasingly relied on overwhelming short-range firepower. The PPSH made that possible. Between 1941 and 1945, Soviet factories produced approximately 6 million PPSH-41s. By 1943, entire Soviet rifle companies carried the weapon. German soldiers began picking them up from the battlefield. They were that much better than the MP40 in the conditions where the Eastern Front was actually fought. A captured Unteroffizier from the 389th Infantry Division, interrogated in July 1943 after being taken at Kursk, explained, "The Russian submachine gun holds 71 rounds. Ours holds 32. In a trench or a house, that difference is your life. Yes, their weapon is crude. Yes, ours shoots more accurately. But when you're clearing a building in Stalingrad, accuracy past 20 meters doesn't matter. Ammunition capacity does." What actually mattered was the reality of combat on the Eastern Front. Buildings, trenches, forests, ranges of 10 to 50 meters where a burst of automatic fire into a doorway was worth more than precision shooting. The PPSH's 71-round drum, that crude, rattling, inefficient magazine, meant a Soviet soldier could enter a building and keep firing, whilst German troops with their 32-round MP40 magazines had to reload twice. The slower rate of fire that German reports mocked? That meant better control and less ammunition wastage. Soviet soldiers called it the papasha, daddy. German soldiers called it the Russian typewriter, and took them whenever they could. The manufacturing implications were equally significant. The PPSH required minimal machining. It could be produced in factories that had never made weapons before. It required no specialist tools, no precision lathes, no skilled gunsmiths. The Soviets set up PPSH production lines in tractor factories, sewing machine plants, and bicycle workshops. By 1943, a single moderately sized facility could produce 3,000 PPSH-41s per day. German MP40 production, concentrated in specialist arms factories, peaked at approximately 300,000 units per year across all of German industry. This wasn't technological inferiority. It was technological sophistication of a different kind. The sophistication of mass production, of designing for chaos, of understanding that wars aren't won by the best weapon, but by the most weapons in soldiers' hands. Soviet engineers had asked themselves, what's the minimum we need for this weapon to work? The answer was stamped steel, a crude drum magazine, and wood. Everything else was bourgeois engineering. The German Panzer IV, in its various marks, represented 4 years of continuous refinement by the time Operation Barbarossa began. Its suspension was sophisticated. Its gearbox was precise. Its optics were excellent. Its armour, though not the thickest, was properly face-hardened. The welds were ground smooth, the interior was finished. Early war German doctrine emphasized tank quality, well-trained crews in well-built machines, supported by combined arms tactics. This made sense. Germany couldn't match the Soviet Union in raw production capacity. Superior engineering would compensate. Then came the T-34. Soviet intelligence had captured German technical reports describing the T-34 following its combat debut in summer 1941. The assessments were brutal. Welding quality is execrable, with visible gaps and inconsistent penetration. Track pins show evidence of poor heat treatment. The gearbox is a primitive crash design requiring exceptional physical strength to operate. Interior finish is non-existent. Unpainted steel, exposed welds, sharp edges. The gun mounting is crude. Optics quality is substantially inferior to German equivalents. Another report noted, the T-34 represents a weapon designed for mass production by semi-skilled labor. In its present form, it would not be acceptable to Wehrmacht standards. These weren't wrong observations. Wartime T-34s were crude. Welds were visible from outside the tank. Interior surfaces were unpainted. The gearbox required a sledgehammer to shift gears. Literally, Soviet drivers carried a mallet for this purpose. The main gun, whilst powerful, had poor optics and a crude traverse mechanism. Early models had terrible vision devices. The two-man turret meant the commander had to load, command, and fight simultaneously. By any measure of individual vehicle quality, a T-34 was inferior to a later model Panzer IV. On paper, this shouldn't have worked. Crude tanks with poor vision, terrible ergonomics, and rough construction should have been death traps. Yet German after-action reports from 1941 onwards tell a very different story. General Heinz Guderian, in a report dated 25th November 1941, wrote, "The T-34 is the best tank in the world. Our anti-tank guns can barely penetrate it. Its armour is sloped brilliantly. Its gun destroys our tanks at ranges where we cannot reply. Its wide tracks give it mobility our vehicles cannot match." A month later, another report from 4th Panzer Division. "We have encountered no fewer than 47 T-34 tanks in the last week. Our losses are becoming unsustainable." What made the T-34 work was what Soviet designers got right. The three things that mattered. First, the sloped armour, not because it was thicker, but because 45 mm at 60 degrees was effectively 90 mm of protection. Second, the Christie suspension and wide tracks, which gave it mobility in mud and snow that German tanks couldn't match. Third, the 76.2 mm gun, which could kill German tanks at 1,000 meters, whilst German 37 mm and 50 mm guns struggled to penetrate T-34 armour even at close range. Everything else, optics, interior finish, gearbox refinement, was deliberately sacrificed to maximize production and these three critical factors. The secret was in Soviet design priorities. German engineers designed tanks to be good platforms for crews. Soviet engineers designed tanks to kill German tanks whilst being producible in quantity. Interior comfort? Irrelevant if the tank can't be built in numbers. Precise optics? Less important than having 5 T-34s for every 3 Panzer IVs. A gearbox that required a mallet? Acceptable if it was simple enough to manufacture in tractor factories. And manufacture them they did. Between 1940 and 1945, Soviet industry produced 84,070 T-34s. German industry produced approximately 8,500 Panzer IVs in the same period. By 1943, Soviet factories were turning out T-34s faster than the Germans could knock them out. Tank Factory number 183, evacuated from Kharkiv to the Urals in late 1941, was producing T-34s within 3 months of reopening. The tolerances got looser, the finish got cruder. Production time dropped from 2,700 man-hours per tank in 1941 to 3,700 man-hours in 1942, briefly increased due to more armour, and then to 2,240 man-hours by 1943 as production techniques improved. German panzer crews quickly learnt to respect the T-34. Otto Carius, one of Germany's most successful tank commanders, wrote in his memoirs, "The T-34 was not a comfortable tank to fight in. We captured several. The ergonomics were terrible, the vision was poor, and the crews were usually poorly trained. But there were so many of them, they were so mechanically reliable, and they could move in conditions that immobilized our vehicles. We learnt to never underestimate them." Another German tank commander, interrogated after capture in 1944, stated, "Their tanks are crude, but crude tanks that move and shoot are better than refined tanks that break down." This wasn't about Soviet engineering being backward. It was about Soviet engineers understanding the actual requirements of mechanized warfare in their theater. Battlefields aren't motor shows. A tank with rough welds that runs for 5,000 kilometers is better than a tank with ground-smooth welds that breaks down after 2,000 kilometers. A tank with crude optics that exists in numbers wins battles over a tank with excellent optics that exists in handfuls. Soviet designers, working under brutal constraints, had identified what actually mattered and ruthlessly discarded everything else. Wehrmacht divisional artillery in 1941 centered on the 10.5 centimeter LEFH-18, a field howitzer representing traditional German engineering. Designed in the early 1930s and refined continuously, the LEFH-18 weighed 1,985 kilograms in action. It required a specialized factory to produce, the Rhine Metal Works at Düsseldorf, where skilled workers machined each component to tight tolerances. Production cost approximately 24,000 Reichsmarks per gun. Manufacturing time ran to 180 man-hours per weapon. The gun was excellent, accurate, reliable, well-balanced. Between 1935 and 1945, German industry produced approximately 6,900 LFH-18S and their variants. Soviet field artillery before 1942 relied heavily on the 76mm F-22 divisional gun, a 1936 design that was powerful but complex. It weighed 1,620 kilograms and required substantial machining. Production was slow and consumed resources desperately needed elsewhere. In 1941, with German forces approaching Moscow and Soviet industry evacuating eastwards, the artillery situation was desperate. Designer Vasily Grabin received orders to create a new divisional gun that could be produced in non-specialist factories by minimally trained workers. The result was the ZIS-3, a weapon that violated every principle of traditional gun design. It employed a revolutionary monoblock barrel construction that reduced machining time. The carriage was a simplified split-trail design using welded, not forged, components. The recoil mechanism was crude but effective. The sights were simpler. The tolerances were looser. Total parts count dropped to just 306 components, compared to the F-22's 482. Manufacturing time, 121 man-hours, a reduction of nearly 40%. Cost, approximately 8,000 rubles, less than a third the cost of the German LEFH-18. German intelligence, examining captured ZIS-3s in 1942, noted, "The weapon represents simplified manufacturing taken to an extreme. Welds are visible throughout. Components show machining marks. Tolerances are excessive. The breech mechanism is crude. This appears to be a weapon designed for mass production with minimal quality control." Another report observed that the gun's light weight, 1,116 kilograms, suggests structural inadequacy for sustained fire. This shouldn't have worked. A crude gun with loose tolerances and visible welds should have been inaccurate and prone to failure. The lightweight construction should have meant poor stability and short service life. Traditional artillery design emphasized weight and rigidity for accuracy. Yet the ZAS-3 became the most produced artillery piece of the Second World War. 103,000 guns manufactured between 1942 and 1945. By comparison, the Germans produced their 6,900 Luftwaffe-18s plus another 6,000-odd of their excellent PAK-40 anti-tank gun. The Soviets were building ZS-3s at a rate of nearly 3,000 per month by mid-1943. What actually mattered was battlefield performance. The ZS-3 fired the same 76.2 mm projectile as earlier Soviet guns. Its accuracy, whilst not matching German standards at extreme range, was entirely adequate at combat distances. Its lightweight, that structural inadequacy, meant a six-man crew could manhandle it into position without a tractor. Soviet gun crews in Stalingrad would wheel ZIS-3s up flights of stairs into buildings to provide direct fire support. Try that with a 2-ton German gun. The manufacturing implications were even more significant. The ZS-3 could be produced in factories that had never made artillery. Grabin designed it specifically to be manufactured using automotive industry techniques, stamping, welding, and simple machining operations that didn't require specialist skills. Tractor factories, railway works, and heavy machinery plants all produced ZIS-3s. Some guns came from factories that had been making locomotives 6 months earlier. Soviet doctrine adapted to exploit this production advantage. Rather than concentrating artillery at divisional level as the Germans did, Soviet forces pushed guns forward to regimental and battalion level. By 1943, a Soviet rifle division might have 200 artillery pieces of various types, far more than a comparable German division's 70 to 80 guns. The Germans had better guns. The Soviets had more guns. In sustained combat, more won. German prisoners consistently remarked on Soviet artillery superiority. A captured Hauptmann from the 44th Infantry Division, interrogated in August 1943 after Kursk, stated, "Their guns are everywhere. We might have better artillery, better training, better fire control, but when they can put 5 shells on a position for every one of ours, our superiority becomes irrelevant." Another prisoner from the 6th Army at Stalingrad noted, "Their guns look crude, they work crude, but they work continuously, and there are hundreds of them." This was the essence of Soviet design philosophy made concrete in steel and explosives. The ZIS-3 wasn't the best gun in any category. It was the best gun when you factored in that you could build 10 of them for every 3 German guns. Grabin and his team had understood that artillery's purpose wasn't to be beautiful or precise beyond practical requirements. It was to put high explosive shells onto enemy positions. A crude gun that did this in quantity was worth more than a refined gun that existed in handfuls. Wehrmacht weapons development in the 1930s followed a pattern established in the Great War. Identify the requirement. Design the best possible solution. Refine through testing. Manufacture to high standards. The Tiger tank, 175 hours of skilled labor. The MG-42 machine gun, 150 hours of production time. The Panzerfaust, simple but requiring specialized facilities. Every German weapon was good. Many were excellent. None could be produced in the quantities needed to replace losses on the Eastern Front. Soviet weapons development followed a different logic. Start with the minimum necessary capability. Design for production first, performance second. Assume manufacturing will be performed by untrained workers in improvised facilities. Assume maintenance will be performed by soldiers with minimal technical knowledge under battlefield conditions. Assume operating environment will be the worst imaginable. Mud, extreme cold, dust, neglect. This wasn't technological backwardness. It was a sophisticated understanding of total war's realities. Soviet designers had learnt lessons from the First World War and the Russian Civil War that their German counterparts had failed to internalize. Wars weren't won by the side with the best equipment. They were won by the side that could sustain production, replace losses, and keep weapons functioning in soldiers' hands. The secret was in Soviet industry's pre-war organization. Stalin's industrialization drive of the 1930s had prioritized heavy industry, tractor production, and infrastructure development. When war came, those tractor factories could build tanks, those automotive plants could build guns, those machine tool works could produce rifles. The entire industrial base was designed to be convertible. German industry, by contrast, was optimized for quality peacetime production. When forced into total war footing, it struggled. Consider the numbers. In 1942, Soviet industry, much of it evacuated, operating in temporary facilities, produced 24,446 tanks and self-propelled guns. German industry produced 9,200. Soviet factories made 33,111 aircraft. Germany made 15,556. Soviet workers assembled 3.4 million small arms. Germany produced 1.4 million. These ratios held through 1943 and 1944. The gap wasn't just industrial capacity, it was design philosophy. Soviet weapons were designed to be mass-produced by the thousands. German weapons were designed to be excellent. Wehrmacht commanders recognized this too late. General Kurt Zeitzler, Army Chief of Staff from 1942 to 1944, wrote in a post-war analysis, "We consistently underestimated Soviet production capacity and the effectiveness of their crude equipment. Our intelligence told us their weapons were inferior. They were inferior in individual quality, but they were superior in the only measure that ultimately mattered. They existed in numbers we could not match, and they functioned in conditions that rendered our superior equipment inoperable." This extended to training and doctrine. German doctrine assumed well-trained soldiers operating complex equipment. Crew training for a Panzer IV took 3 months. Soviet T-34 training was sometimes 3 weeks. The Germans produced better crews. The Soviets produced more crews and designed their tanks to be operated by those minimally trained crews. A T-34's crude gearbox didn't require a skilled driver. It required a strong driver. Soviet recruitment could provide that. The reality of combat showed that crude simplicity had its own sophistication. A PPSH-41 with 87 parts was harder to break than an MP-40 with 36 parts? No, the PPSH was easier to fix because its crude tolerances meant replacement parts from different factories would still work. A T-34 with rough welds was structurally weaker. Not if those welds were overbuilt because Soviet welders couldn't achieve precision. A Mosin Nagant with loose tolerances was less accurate. Irrelevant when your soldiers are shooting at ranges where both rifles hit center mass. Soviet engineers had discovered, or perhaps been forced to discover, a principle that Western military thinkers would only fully appreciate decades later. In complex systems under stress, simplicity, and redundancy defeat optimization. The crude Soviet weapon that could be quickly repaired, easily produced, and reliably operated by a frightened conscript in a frozen trench was more valuable than the precise German weapon that required a skilled operator, a clean workshop, and replacement parts from Stuttgart. May 1945, Berlin. A Soviet lieutenant examines a late-war German Sturmgewehr 44, Hitler's last wonder weapon, an assault rifle of remarkable sophistication. It has selective fire. It has a modern intermediate cartridge. It has excellent ergonomics and good accuracy. Approximately 425,000 were produced, too few and too late to matter. The lieutenant sets it aside and picks up his PPSH-41. Crude, simple, stamped from sheet metal. There are 6 million of them. He's carried one from Stalingrad to the Reichstag. This wasn't about Soviet weapons being better in any conventional sense. The Kar-98K was a better rifle than the Mosin Nagant. The MP-40 was more refined than the PP-Shish. The Panzer IV, in its later models, was arguably better tank for tank than the T-34. The German guns were more accurate, but better didn't win. Crude won, simple won, mass-producible won. The Germans had designed weapons for the war they wanted to fight, a short, decisive conflict where superior technology and training would overwhelm less sophisticated opponents. The Soviets designed weapons for the war they got, a brutal, attritional struggle where production capacity, reliability, and replaceable soldiers mattered more than precision engineering. Wehrmacht reports had been right to call Soviet weapons crude. They'd been catastrophically wrong to think that mattered. What made crude work wasn't any single feature, but rather a complete design philosophy. Start with what you can actually produce. Design for the worst possible conditions. Assume your users will be undertrained and your maintenance will be field expedient. Accept that individual performance will be compromised. Recognize that having 10 crude weapons beats having 3 excellent ones. Soviet engineers, working under constraints German designers couldn't imagine, had discovered a counterintuitive truth. In total war, crude and simple defeats refined and complex. Not because crude is better, but because wars aren't won by the best equipment. They're won by enough equipment in enough hands, functioning reliably enough, for long enough. The Mosin Nagant with its loose tolerances, the PPSH with its stamped receiver, the T-34 with its visible welds, the ZIS-3 with its simplified construction. These weren't crude because Soviet engineers didn't know better. They were crude because Soviet engineers knew exactly what mattered. Battlefields aren't testing ranges. Soldiers aren't engineers. Factories can't run on peacetime assumptions during total war. The Wehrmacht learnt these lessons in frozen trenches outside Moscow, in the rubble of Stalingrad, in the killing fields of Kursk. They learnt that crude weapons in the hands of millions would defeat excellent weapons in the hands of thousands. They learnt that a rifle that works in winter beats a rifle that shoots tighter groups in summer. They learnt that simple and mass-producible wasn't a compromise, it was the requirement. The Nazis called Soviet weapons crude. They were right. Crude turned out to be exactly what was needed, not despite its crudeness, but because of it. That was the lesson German engineering excellence never quite learnt, and the reason why crude weapons won the war.